Transistors. Transistors are solid-state devices used for amplifying, controlling, and generating electrical signals. They are used widely in electronic equipments such as pocket calculators, radios, and also in communication satellites. In 1947, J. Bardeen and Walter Brattain were the first to invent the transistor by adding another junction to a p-n junction diode which could control the flow of majority charge carriers. William Shockley in 1951 made the modern version of the transistor. Transistor is a minute semiconducting device which performs most functions of a thermionic valve, but with greater efficiency. A transistor can act as a switch or an amplifier. The simplest form of the transistor, called the junction transistor, consists of a semiconducting material in which a very narrow N region is sandwiched between two P regions, or a very narrow P region is sandwiched between two N regions. The former configuration is called a PNP transistor and the latter is NPN transistor. Transistors are normally made by growing one region onto the other. Observe that all the three blocks of the transistor are not equal in size. This is how a PNP and an NPN transistor are represented. The operation of the two transistors is essentially the same, hence only the working of a PNP transistor is explained. The structure of the PNP transistor, together with its circuit symbol, is shown here. The outer regions are called the emitter and collector, and the narrow central region is called the base. The configuration contains two junctions, namely the emitter-base interface and the collector-base interface. We can consider the transistor as two diodes placed back to back. To obtain transistor action, the doping levels in the different blocks are kept different. The emitter is of moderate size and heavily doped. The doping supplies a large number of majority carriers. The base is the central block. It is very thin and lightly doped. The collector collects a major portion of the majority carriers supplied by the emitter. When proper voltages are connected to the terminals of the transistor, the charge carriers move across the transistor. For the transistor to behave as an amplifier, the emitter is forward biased, while the collector-base junction is reverse biased. Two depletion layers are formed, one at the emitter-base junction and the other at the collector-base junction. Since the emitter is heavily doped relative to the base, and since the emitter-base junction is forward biased, a large number of majority carriers, holes in this case, will flow from the emitter towards the base. These constitute the current through the emitter, IE. These holes have a tendency to combine with the electrons in the N region of the base. Only a few holes are able to combine with the electrons in the base region, giving only a small base current, IB, because the base is lightly doped and very thin. Most of the holes coming from the emitter are able to diffuse through the base region to the collector region. In the collector region, these holes see the favorable negative potential, and hence they easily reach the collector terminal to constitute the collector current IC. If IE, IB, and IC are emitter current, base current, and collector current respectively, then the emitter current is given by IE is equal to IB plus IC. This base current IB is very small, but a small change in it can significantly change the collector current IC. If the transistor is properly biased, the collector current or output current is directly proportional to the base or input current, and the transistor acts as a current amplifier. Thus, the transistor may be used to amplify a small signal. In a PNP transistor, current is carried by holes inside the transistor and by electrons in the external circuit. But in an NPN transistor, current is carried by electrons both in the external circuit and inside the transistor.